Dear students, we have explained consumer equilibrium for two goods. Now we generalize it to a case of n goods using some mathematics. For graphical presentation, we can consider only two goods. For mathematical presentation, we can generalize it into n goods. And in the real world, a consumer purchases n goods. So what we consider here is an interior optimum for n goods using little algebra, calculus, etc. using the concept of constraint optimization. Now we assume that u is a function of x1, x2, etc., xn is a function of x1, x2, etc., xn. And the objective of the consumer is maximization of utility, and it is subject to the constraint that px into x plus, px x1, x2, etc., xn, subject to the constraint that p1 x1 plus p2 x2 plus etc. pn xn is equal to I. x1, x2, etc., xn are the quantities of commodity x1, x2, etc., xn. p1, p2, etc. are the prices of commodities 1, 2, etc., n. I is the money income. We write the constraint as I minus p1 x1 minus p2 x2 minus etc. pn xn. pn xn. To maximize u, subject to the budget constraints, we first set the Lagrangian function phi. The Lagrangian function, familiar to you. The Lagrangian function phi is equal to u x1, x2, etc., xn plus lambda I minus p1 x1 minus etc. pn xn equated to 0. The Lagrangian function. Now we differentiate phi with respect to x1, x2, etc., xn and lambda, equate it to 0, we will obtain a total of n plus 1 equations, n plus 1 equations. And solving these n1 plus equations for n plus 1 unknowns, we will obtain the optimal quantities of x1, x2, etc., xn and also the value of lambda, and it will be the first order condition for interior optimum. So what are they? So dou phi by dou x1 is equal to dou u by dou x1 minus lambda p1 equal to 0. Second is nth one, dou phi by dou xn is equal to dou u by dou xn minus lambda pn is equal to 0. A total of n equations. Total of n equations. And dou phi by dou lambda is equal to I minus P1 x1 minus Pn xn is equal to 0. N plus 1 equations. N plus 1 derivative equations. And these n plus 1 equations can be solved for n plus 1 unknowns will give you the optimum quantities x star 1, x star 2, etc. x star n, and also the value of lambda. The value of lambda. And this equation is the necessary condition for maximum, but not the maximum condition. To ensure maximum condition, the sufficient condition for maxima, we have to resort to matrix algebra. We have to use what is known as Hessian matrix, etc., which we are not attempting here. And remember this, if the indifference curve or the preferences satisfy all the axioms, first order conditions is both necessary and sufficient. There is no need for checking the second order condition. That is, first order condition together with the diminishing MRS is sufficient for necessary and sufficient condition. Now, let us see what are the implications of first order condition. Now, the first order conditions given by these equations can be written in different ways. For example, for any two goods xi and xj, for any two goods xi and xj, we can write it as dou u by dou xi by dou u by dou xj is equal to Pi by Pj. So, I and j, two commodities. Dou u by dou xi divided by dou u by dou xj is equal to Pi by Pj. That is, mu xi by mu xj is equal to Pi by Pj. That is the ratio of marginal utilities is equal to the ratio of prices. And as this is equal to MRS xi xj, this can be written as MRS xi xj is equal to Pi by Pj. And this is what we have discussed graphically. That is, equilibrium occurs when the subjective rate of substitution is equal to the market rate of substitution. Now, what is lambda? From these equations, lambda can be derived as what? Lambda is equal to dou u by dou x1 by P1 is equal to dou u by dou x2 by P2 is equal to etc. dou u by dou xn by Pn, and that is equal to mu1 by P1 equal to mu2 by P2 is equal to mun by Pn. And as we have seen, mu1 by P1 is the marginal utility from the last dollar, if the last dollar is spent on commodity x1. So, lambda is nothing but marginal utility per dollar, or it is the impact on the objective function caused by a 1 unit change in the constant of the constraint. That is, if income increases by say $1, its impact on utility is what is known as lambda. So, for equilibrium, the requirement is marginal utility per dollar should be equal whether it is spent on x1, x2, etc., xn. And this is known as marginal utility of income. That is, lambda is dou u by dou I. If this is the utility function and lambda is the impact on the objective function caused by a 1 unit change in the constant of the constraint, that is dou u by dou I. That is marginal utility of income. Marginal utility of income. That is it. So this is the specification in terms of by using n commodities, using the technique of constrained optimization. That is the generalization of the graphical methods we have discussed. The Lagrangian multiplier method for constrained optimization.